just so you guys know, in your Canvas homepage, I purposely put these videos up here. And just so you guys know, there's a lot of videos, right? There's so many of them that I just made it where it's links. If not, this would just go, right? Because each of these videos are actually from, oops, sorry guys. I'm sorry. All of these videos are actually from my college algebra, okay? So these videos are college algebra videos, all right? Uh-oh. So if you're missing some things, or in college algebra you decide to learn and then dump your information, then I would tell you that you're going to need these videos. And I'll also tell you that every other pre-calc class does not teach anything in chapter 1, chapter 2, nor chapter 3. They usually start at chapter 4. All right? So if you're struggling with anything in chapter 1, chapter 2, and chapter 3, you guys really need to catch up to it. Now, am I covering some of the stuff? Yes. All right? Because I know that as a student myself, sometimes I need reminders. But the rest of it needs to be up to you. So it's got to be kind of a balance, because there's no way that I'm going to finish anything in pre-calc if I only go back to everything that was already learned last semester. Make sense? Okay. So we got to kind of meet in a happy place. Okay. So am I kind of hitting a couple other things that maybe you do know? Yeah. But there's also things that people need reminders of. Okay. Like piecewise function, like transformations. Those are typically major things that people actually need some time with. And today I'm actually trying to cover 7 pages of notes. Oh, all right. So it's going to move along pretty, I won't say smoothly. I would say it's going to move along pretty fast. So do the best with your notes, but remember and understand that all of these notes are going to be posted. Oh, dough. It says the internet was unstable, remember? Welcome back. You were saying my internet was unstable, so that's why. And it's still unstable. Welcome back. You were saying my internet is unstable, and apparently it's still unstable. Which Wi-Fi am I on right now? That's why. Let's go back to. Hold on, people at home. All right, let's continue. I don't know how we're gonna cover 7 pages of notes with these internet issues. All right. So again, don't forget that, like what we did on Tuesday is posted up there, right? So if you look at the left link, is a PDF of everything I did on Tuesday, if it ever shows up. So everything I did on Tuesday is going to be right there. And then the video is on the right, which obviously there was a long time where there was nothing. It was just like going over the Canvas page and stuff like that. And then today's video will loop up right here. The May 14th and May 16th is the condensed. It was a live lecture that I did in the summertime. So if you guys want to watch that, that will also cover some of this as well. Okay. All right. Function and graph of functions. Function notation. So basically, we're replacing y with f of x. We know the operations, right? But the question is, can we do these operations on a graph? Right? So if I want to say f plus g of 3, what does that actually mean? It means I have to find f of 3, and I got to find g of 3, and add them. But you guys already knew that, yes? I hope. Fingers crossed. And I have this already marked. There's my x value, that's the 3. So I'm just looking for the y value when the x value is 3. And I make sure that I hit the correct line as well. So f of 3 is actually -1. G of 3 is actually 4. So f plus g of 3 is going to equal to 3. Any questions on that? Nothing? 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 Now, most of the time with the quotient rule is that they're going to really ask you about the domain, really to test you. Do you know that, dividing by 0, radicals in the denominator, how do we deal with the domain? Okay. We're going to skip the composite for now, because the composite is more like the human centipede, right? You feed the head, the waist of the head feeds the next head, right? That's a human centipede. That's a composite, right? All right, so let's talk about this right here, the difference quotient. Do you guys remember the difference quotient? What is the difference quotient finding? What do we solve for when we solve for the difference quotient? Anybody? 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 Oh boy. Okay. So the top, f of x plus h. What does that get us? Well, if we were to say just f of x, what does that really stand for? Y. Awesome. Right? So f of x is just a y value, right? Where x is x and the y would be f of x, right? F of x plus h means what? That the x value is what? X plus h, right? And what's the y value? F of x plus h. Does that make sense? So here, let me do this. So this is a point x comma y, right? This is a point x comma, oh, I'm sorry, wrong. X plus h comma f of x plus h, right? Another x comma y, right? So isn't this right here just the difference of those two y values? Okay. When have we ever taken the difference of two y values? Nah. Where else do we take the difference of two y values? The slope, right? And then what would we do on the bottom of the slope?
It would be the
Awesome. So take the x value. Take the x value. Take the difference of those two. What would you get? If you take the x value, subtract it to this x value, what would be my result? Isn't it h? Right? X plus h minus x, wouldn't that just give me h? So guys, the difference quotient is just another formula for slope. It's just another formula for slope. H is typically known as really, 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 really small. Okay? So if I took a parabola and I put this equation into it, from the naked eye, if I just took a really small section and blew it up, it will look like a straight line, right? A parabola is curved, but if I can take a small enough section, it's going to look like a straight line. So that's what the difference quotient is, okay? It's just a slope formula, I should say another slope formula, right? So we're actually going to learn, what, 3 different slope formulas? Slope formula that you already know, change in y over change in x. The difference quotient. Looks different, but it is the same. And the other one's going to be average rate of change. Okay? All right, so since we know that this is another slope formula, then let's go ahead and find the difference quotient of this right here. So the difference quotient here, if we were to take it for this function, we have f of x. We're given that. That means we need an f of x plus h, and then we got to subtract them. So what is going to be f of x plus h? Well, how do I deal with that? I have to plug it into the equation, right? Wherever there's x, I want to replace it with x plus h. Yes, you do have to double distribute or FOIL this. And this is just going to be distribute. So what you're going to get here is going to be, no, I'll just leave it in red, x squared plus 2xh plus h squared minus 2x minus 2h plus 2. Don't worry, there's no like terms. 0 like terms. Do we know how I got everything here? Yes, we're good? Are we sure? Really, really sure? This right here is just foiling this out. Because you get x squared plus xh plus xh plus h squared. All right? And this is just the distribution of that, and then plus 2. All right. So the difference quotient says to me that, hey, I'm going to take the f of x plus h minus f of x, and then divide it by h. Okay. So if I look at this, I have f of x plus h, right? It's right here. I have f of x. It's right here. But because of that subtraction in front, I have to put parentheses around it and then divide by h. Now, every time you do the difference quotient, the f of x should disappear. If it doesn't disappear, you screwed up somewhere. Right? Something went wrong. Because if you notice what happens, x squared minus x squared. Bye-bye. Negative 2x minus a negative 2x. Bye-bye. Positive 2 minus a positive 2. Bye-bye. Everybody see that? All 3 of those go away. So I'm going to only have left 2xh plus h squared minus 2h all over h, which is going to be left with 2x plus h minus 2. Ask your questions.
So when we have like h plus 1, it would then be h plus 1 for x.
Correct. Correct. So, because, hey, here's the thing. If I was to ask you to find f of 2, you would just replace all the x values with 2, right? It doesn't matter what's inside the parentheses. When it's asking you to do that, that's what you're replacing x with, right? So if I was to say, hey, find f of, oh, that's a weird looking thing, a butt cheek, then you would just put butt cheeks in here. Make sense?
Yes.
So it doesn't matter what is inside the parentheses. Wherever x is, we're going to replace it with that. If it's a person, we're going to replace every single x value with a person. If it's my left foot would go in there. Okay? Although I don't know what that would equal to, or these butt cheeks would equal to. We're looking butt cheeks as well. But anyways, any other questions? Are we okay here? Do we know how it got from here to here and here to here? Yes? There's a GC of h here. Factor that out. Cross out with the h on the bottom. Hence, I got that left. Now, one of the things I said was the f of x should go away. Yes, it should. Which means that only my h terms would be left. Okay? So essentially, that's what would happen. Okay? This is also called a derivative for the ones that are going to be moving on to calculus. That would be a derivative. So, let's talk about, let me see if it's in 3.3. Yeah. Yeah. All right. So let's talk about property of functions. We have even functions. We have odd functions. Someone's just asking me about this today. So what's an even function? Even function is this right here. It's a parabola, right? A parabola, I know. All right? It's a parabola. That's an even function. A sad parabola is also an even function. What does it mean? So let's take a look. If I took this point right here and this point right here, right? What can you tell me about the x values of these 2 points here? They are?
They're equal? I mean, no, they're opposite.
But equal. Meaning, if this was -2, this would be +2. X value. How about the y value? Same. Very good, right? It's the same. Does that make sense? If I was a parabola, and I should say, if my arms was a parabola and I'm the y-axis, this is the even function because the x values are opposite, but the y value is the same. Is that fair? This is an odd function. That means it has symmetry through the origin. So if you look at my sternum as the origin, okay, what can you tell me about the x values of these 2 points? Opposite. And the y value? Also opposite, but the same values. Does that make sense? Okay? So that's what's meaning by even versus odd. Even versus odd. Okay? Ow, that hurts. All right? So that is exactly what these are saying here. It's saying that if the function's even, the x value are opposite but the same. That's what you guys told me, right? Opposite but the same. But notice that the y value both stay as positive y values. X values, opposite but the same. Y values, the same, right? They're equal to each other. Make sense? That makes it an even function. For odd function, you told me that the x values were opposite but the same. Notice the y values. Opposite but the same as well. right? F of x equals negative f of x. Everybody see that? So for even and odd function, those two statements stand true. So what's the 3 steps I need to do when I'm looking for even or odd function? First, I got to look at my given function, f of x. Then I'm going to find negative f of x. Then I'm going to find f of negative x and compare it to step 1 and step 2. Is that fair? All right. So again, take the f of x, negate that function, then solve for f of negative x, and compare that to 1 and 2. If it looks like 1, even. If it looks like 2, odd. If it looks like neither, neither. Is that fair? So let's go through these steps. So I'm given g of x. Step 1, done. What's step 2? Find negative g of x. What is that going to equal to? Negate it. I think that's what all the mumbling was saying. I think that meant 2x to the third minus 3, sir. Right? So I found these two, yes? So step 1 done, step 2 done. True? Now I'm going to look at step 3. Step 3 says I got to find g of negative x. Wherever x is, I'm going to replace with negative x. What does negative x to the third give me? Negative x to the third. Oh, wow. So if that's going to give me a negative x to the third, I multiply by negative 2, what is that going to give me? Excellent. So now I'm going to compare. Does this look like this? No. So you're saying that g of x does not equal to g of negative x. Conclusion? Not even. Then I want to take this and compare it to this. Are they the same? No. So you're saying negative g of x is not equal to g of negative x. So not odd. So this must be neither. Does that make sense? So that means it doesn't conform to this, and it doesn't conform to this, so therefore it's neither. Questions? We're okay? No questions? I know I got to go through 7 pages of notes, but I still want to answer your questions still. But there's none. Are we sure? All right. Now, if it does look like one or the other, then it'll be even or the odd. Okay? So the function is increasing, decreasing, or constant. It's all dependent on as we are going from negative infinity to positive infinity. In other words, going from left to right, right? So we go from left to right here. I'm going from here. I'm going downwards, so I'm decreasing. Then I'm increasing, and then I am decreasing. Does that make sense? So there's nothing in here that's going to be constant at this point in time. Now, with these intervals, however, these will always be open intervals. And the reason is because at these points right here, guys, these are transition points. So I can't say that at that point in time, if it's decreasing, increasing, or a constant, is a transition. Right? Just like in sports, when you're transitioning from offense to defense, you really don't know. Well, besides football, I guess you do know. Right? But most other sports, when you transition from offense to defense, I guess volleyball too, right? But most sports, when you transition from offense to defense, there's not like a clear cut of when that happens, right? So same thing with these. These are transition points, but they're not necessarily increasing degree. And that's the reason why we use open intervals. However, because this stops here, then that endpoint, if it's actual endpoint, then we can go ahead and call those closed. Does that make sense? But everything else has to stay open. The transition from increasing, decreasing is always open intervals. Okay? And of course, if I was to say to you, hey, give me the intervals where it's increasing versus decreasing, you're going to be like, the x values or the y values? Would anybody ask me that question? Is it the x values or the y values? If I was to ask you to give me an interval of increasing, would you give me x values or y values? Y-x and not y.
Wait, because the y value has a certain point where it stops increasing?
Yeah. And? Yeah. Y value is a range, but it's still an interval, right?
The y value is dependent on the x value?
Yeah, it does. But how does that help me know which, if I give the x interval or the y interval? So let me give you guys an insight. If I took a piece of paper, okay? Oh, sorry, you guys don't see me. There we go. If I took a piece of paper and I did this, okay? And I was to look at this picture like this, right? If I was to cut to a certain interval, would I see the increasing, the decreasing, and the constants? Like I would see almost the whole thing, won't I? Because if you guys think about it, if I cover this up, doesn't really help with anything, does it? Because I see decreasing here, I see increasing here, I see decreasing here, right? However, if I took this and did this, right, and I looked, I can actually split up the so-called decreasing versus increasing versus decreasing. Does that make sense? So here I can actually separate what's increasing, what's decreasing, versus here I'll see everything. Parts of increasing, parts of decreasing, all of that, right? Make sense? Questions? So that's why we use x values and not y values. Is that fair? Okay. And don't worry about that gibberish over there. That's kind of intimidating. Just look at it. Going from left to right, if it's going up, it's increasing. If it's going down, it's decreasing, right? So my interval for Increasing would be and decreasing because it ends. Apparently in those videos I talked about Chinese as well. I don't know why. We're okay there? So I got local max, local min, and then down here it says absolute max, absolute min. What's the difference between those two things? So the local is like the relative max and min, right? At the local bar, relatively speaking, if it's like a really bad dive bar and nobody goes to, I might be the prettiest one there. But clearly in the world, there's a lot of other pretty people there. But in that local dive bar, when people have no teeth and all that jazz, I might be the prettiest one there. That's why I hang out at those bars. No, I don't. That's why I have ugly friends too. But they are typically only peaks and valleys. Okay? So if I look at a parabola, right? I shouldn't even call it a parabola. Well, yeah, I should. No, let's do it this way. So let's say I have something like this, right? If I have a peak of this elbow, that is a local max, even though if I know that this goes up higher. This right here, this elbow here would be my local min, even though if I know that this arrow points lower. Does that make sense? But it has to be a peak or valley. If there's no peak or valley, then there's no local max or mins. Make sense? Now, absolute max and mins could be the peaks and valleys. Could be. But it is talking about the highest point and the lowest point. However, notice what it says. It only exists in a closed interval. So in other words, it can't go to negative infinity or positive infinity because with negative infinity and positive infinity, we use parentheses, right? So therefore, those are open intervals. But again, absolute means it is the highest point. It is the lowest point. Yes?
So was that what we saw in the graph above?
Oh, we're going to talk about these graphs below.
Oh, okay.
Right? So just know that local has to be peaks and valleys. And it can be things that point to negative infinity and positive infinity. The absolute has to be a closed interval. That means it cannot have those arrows. Okay? And it is the highest point and the lowest point. And it has to be closed intervals in order to have those absolutes. Because we can't say that positive infinity is the absolute max and the negative infinity is the absolute min. Okay? So if we look at these right here, this graph, this first graph right here, do I have a local min and a local max? Yes, because there's a peak and there's a valley, right? So this peak right here is a local max. This valley right here would be my local min, right? Do I have a global, absolute max and absolute min? Yes. right? Because that absolute min is lower than the local min. So, because that's the lowest point versus this is the highest point of that graph. How about the second graph? I have a local min and I got a local max, yes? Because those are peaks and valleys. What is the absolute max and absolute min? Is it these endpoints here? No. Because this point here isn't lower than the local min, right? And this point is not higher than the local max. So therefore, our local max is also our absolute max. Our local min is also our absolute min. That can happen. And how about that right there? Can it have an absolute max or absolute min? Why? Because it's open. It'd be open interval, so therefore we can't have absolute max or mins. How about my local max and local min? Because where the peak is, it's open circle. Right? So it's like, yeah! Ah! Right? Same thing with the bottom. The local min, where it's supposed to be, is also not existing. So that's why there's none there either. Oh, look at that. Another form of slope. Average rate of change. And it's always funny to me because average rate of change always confuses people, and I don't know why. Not sure why. So here's my question. If I was to take these y values and change them to function notation, what would they be? If I take y sub 2 and change it to function notation, what would it be? It would be f of, you're right, f of what? Which x value would it be? X sub 2, right? Doesn't this x value correlate with this y value? And this x value correlates with this y value, right? So wouldn't this just be f of x sub 2? And this would be f of x sub 1? Huh, I wonder how I came up with this average rate of change. Huh, interesting. Make sense? So that's why I never understood why the average rate of change was so confusing. Because if we would just convert those to function notation, it will automatically pop out. Now, the question for average rate of change is different because what it would say is this. It would say find the average rate of change when f of x is equal to x squared, x sub 2 equals 0.5, and x sub 1 equals 0. So that's the way it would ask the question of finding the average rate of change. It would say find the average rate of change when the f of x is this, and then my two x values, right? So if I'm given two x values, to find the average rate of change, I will have to find the two y values. So I have to find f of x sub 2, which is equal to, don't go too fast, guys, please. Don't confuse me. Right? Because if I put in 0.5 into here, 0.5 squared isn't that 0.25? Yes? So now if I put it into the equation, questions? Nothing? Are we good with this? No questions at all? Are we sure? Yes?
You got 1/2 of that because 0.25 is half of 0.5,
Yeah. Or you can look at it this way too, right? Because essentially this is 1/4 divided by 1/2. So you got 1/4 times 2 over 1. Mm-hmm. All right. So this thing right here, guys, this is called a secant line. The blue line right there is called a secant line. It's a line that cuts through 2 points of a curve. And this is where the average rate of change comes into play, right? Because if you guys look at this point here, this is the slope. Then this is the slope. At this point here, this is the slope, and this is the slope, and this is the slope, right? So if you guys look at it, these are all different levels of slope. So throughout that interval, there's an average slope or average rate of change. All right? That's where the secant line comes into play. Right? Now, sometimes with a secant line, number one, we got to find the slope. So if we have 2 points, we can find the slope by the change of y over the change in x. But more importantly, sometimes what we need to do is we need to also find the equation of that line. Right? So that's where everything comes into play. So number one, what are the two things we need to write an equation of a line? One,
The slope.
two, we don't, it doesn't have to be that specific, right? Just a point. Right? It'd be great if we had the intercept. It'd be awesome, but we don't really need to have to be that specific. We can just get a point. As long as we have a point, we're good, right? All right. So over here, we can read 2 points, right? So these 2 points are what? 0, 0, and what is this? Ooh, be careful. Be careful. This is 1/2, comma, a quarter. Is that right? Am I right or am I wrong? I'm right? Because I did 4 spaces as 1, right? The cool part is that I can just look at these 2 points and get my slope, wouldn't I? Because it's just rise over run, right? I don't really have to use that even the half and the quarter either, right? I can look at it as how many boxes or how many units I went up versus how many units I went to the right. So when I look at this, my slope is still 1/2 because I went up 1, right 2 to get to the other point. So here I can actually say my slope is equal to 1/2. Is anybody trying to disprove me right here now? I'm okay with it. I'm good with that. I'm just human, so I can be wrong. I've been wrong before. Usually I apologize. So I'm good? Slope is 1/2? All right. So if I have a point and a slope, which I just found, 2 points and a slope, how do I go about finding the equation of a line? One is,
Well, since you have a slope, you can say y equals 1/2 x plus b. And then since you also have a point, you can use the values of the points into the equation to find b.
so what he's saying is I can use the slope-intercept form, which I shorthanded as SIF, which is y equals mx plus b. In this case, it's going to be y is equal to 1/2 x plus 0, because the y-intercept is 0, right? I can also use PSF, which I shorthanded to point-slope form. Okay? And then, once in a while, we might be asked to put it in the general form, which is ax plus by equals c. Now, that's not going to help us find jack squat. All right? We want to find the equation of the line and then put it in that form. Okay? And the ax plus by equals c, the a is typically going to be positive. Okay? But either the SIF or the PSF, you're going to get the same equation. You're going to get the same equation. No other questions? Let's talk about piecewise function. We're almost done. Again, this should be all review. You guys should be like, oh, this is all cake. If you're crapping yourself right now, you might have some work to do. All right? So piecewise function. So piecewise function is kind of like the Frankenstein of functions. All right? So in other words, it could be 2, it could be 3, it could be 4 different functions, and they just kind of chop it up, and then they plug them together. Right? But remember, it's still a function. That means it still has to pass the vertical line test. Right? So understand that. But again, it's piecing them together. So it's like Frankenstein, right? Frankenstein is not going to have like 5 eyes. Right? Frankenstein is like a real person with 2 eyes, 2 ears, and so on and so forth. Right? So it's not like they're like plastering different eyes on him just to make him look anything else. All right? All right, so here I wanted to work on going the opposite way. I have these 2 lines right here, the the two horizontal and vertical lines that vertical and horizontal lines that I drew is the sake of finding the slope of those two lines. That's all it is. Okay. So if I was given this right here, I should do it this way. If I was given this right here, the question is, how would I write the equation for the so-called piecewise function? Okay? So number one, I got to find the equation of these two lines, right, in order for me to write that. So that's the reason why I did this, so that I can find the slope of these two lines, right? So what's the slope of the blue line? Is it positive or negative? Negative what? -1. And the slope of the red line? Awesome. So what's the equation of the red line? Say And the equation of the blue line? Yes? That was like very confident. Nose angled upward. Yes, sir.
The equation for the blue line is y equals -x.
That's it. Very good. Okay, so here's the thing. Notice that this equation goes from negative infinity all the way to 0. Does it include the 0? Yes, it does. That's why this is a closed circle. And the red line goes from 0 to 5. Does it include the 0? No. Okay? So again, this has to pass the vertical line test. So that means I would write this as this. F of x is equal to negative x, comma, from negative infinity. Well, actually, I don't even need to do that. I can say when x is less than or equal to 0. And f of x is going to equal to negative x plus 5 when from 0 less than x less than or equal to 5. Does that make sense? Because when I say less than or equal to 0, that means it's from 0, including 0, all the way to negative infinity. Right? When I say between 0 and 5, including 5 but not including 0, that means I have to have an open circle at 0 and then closed circle at 5. Right? So what is f of 3 here? Which equation would I use if I asked you for f of 3? The blue or the red? The red. Because the x value of 3 lies between which interval? Does it lie between less than 0 or between 0 and 5? It lays between 0 and 5. So that means I would use a red equation. So this would be right? And for negative 3, would you use the red or the blue? The blue. And it's very easy to see on the graph too, right? Because if x value is negative 3, you can see it. It's going to be the blue. For the 3, you can see it. It's got to be the red. There's no way for me to go from here and go over there. Right? All right, so what if I gave you this function? So one was from the graph to writing the piecewise function, and one is a piecewise function, which I got a graph, right? The two different directions. So here it is. So f of 2. Red, blue, or purple? Blue. -2. Red. Agreed? Anybody disagree? No? Okay. We're okay? Are we sure? All right, so how do I want you to graph these? So you guys see that there's these key points right here, right? The -4 and 0. So notice I put down -4 and 0 for this function. Everybody see that? So these are my key endpoints, and I know that this is going to be what kind of line? Starts with die and ends with agonal. Oh, wow, you guys are good. Yes, that's going to be a diagonal line, right? And what is this going to be? A parabola. And what is this going to be? Diagonal line. Make sense? All right. So that's the reason why this, I only need 2 points because I just needed 2 points to make a straight line. Where for this one, since it's a parabola, I have 3 points. Because I know there's going to be a curve to it, so I need to know where that middle part is so I can make that curve. And then over here is a straight line again. Oh, I made more than 2 points, but I don't really need all 3 points. Okay? So for me, I want to make sure that I get the red correct. So at -4 means it's included at -4. Is that right? So I know at -4 it's going to be a closed circle. And at 0, it's going to be an open circle. Right? And if I plug in -4 in there, I'm going to get what? -2, and for 0, I'm going to get 2. Is that right? Everybody got that? So I'm going to plot those 2 points. -4, -2. You say, and this is going to be a closed circle. Then I got 0, 2. That's going to be an open circle. And I'm going to have a straight line going from here to here. Boom. I just got that first part done. Is that fair? Pretty easy? Questions? Everybody know how I got the -2 and the 2? Yeah? Okay. So let's look at the 0, 1, 2. Because I'm looking at this interval here. It's going from 0 to 2. What I know is that at 0, it's going to be a closed circle. And at 2, it's also going to be a closed circle. Right? So let's take a look. 0 squared is 1 squared, 2 squared. All right, so let's plot those points. 0, 0. Wow. One, 1, and then 2, 4. Boom, done. Questions on that? Oh. What do you mean? No, thank you. You're absolutely right. Because we just said it was closed, right? And then last but not least, the last one says this right here. It's 2 and beyond, but not including 2. So that means at 2, it's going to be an open circle. And at 4, it's just going to be an arrow, right? So let's plug that in. If I plug 2 in, I get what? 3. 3 in, I get 2. 4 in, I get 1. Is that right? So 2, 3. Three, 2. So it look like that. So that would be my so-called piecewise function. Does that make sense? So notice that I mainly use the endpoints. So I know what's open circle, what's closed circle. And I just graph those. Okay? We're okay? All right. The last set of notes that we need to go through. Where the heck did that go? Duplicate. There we go. Those are some high heels up there. All right, so see, these are some parent functions slash key functions, meaning starting points. Okay? So some of these you guys already know. Some of these guys you guys need some help with. But most likely, anytime they talk about key functions or parent functions, they're going to give you that function. That's where you're going to start your points from, is from the key functions, right? So if you see a square term in there, chances are the parent function is going to be the x squared. So you use points from x squared. Negative 2, 4, negative 1, 0, 0, 0, 1, 1, 2, 4. If you see a square root somewhere, chances are the parent function is the square root of x. So you use those points. 0, 0, 1, 1, 4, 2, 9, 3. Does that make sense? Okay? We want to use those points that way. So we typically always go back to the parent function, and then we do our transformations from those points. Okay? Don't worry about writing the parent functions down or the key functions, because again, this is going to be posted anyways. All right? I think more concerning that you ought to write down is this piece right here. So if you guys look at this form right here, we have what's inside the parentheses versus what's outside the parentheses. What's inside the parentheses, it affects the x value. In fact, the inside the parentheses doesn't just affect the x value, but everything is backwards, inversed, and opposites. So if inside the parentheses it tells you to add, you subtract. If it tells you to subtract, you add. If it tells you to multiply, you divide. In fact, it's so opposite that we don't even go with PEMDAS inside the parentheses. We go with SADMAP. So that means the order of operations is even backwards. Everything outside the parentheses affects the y value, and everything straightforward. Okay? So think of everything inside. Everything's kind of like, whew. Drunken stupid. Everything outside, whew, back to normal. Okay? So let's talk about that. So here's inside. So again, it affects the x value. So I'm going to use a parabola, for example, right? If I tell you to subtract some value from the x, you're going to add it. That means I'm going to shift right when it says subtract. When I say to subtract, if I tell you to add, I'm subtracting the x value. That means I'm going to shift to the left. Okay? Now, If I was told to multiply the x value, that means you're going to divide. Well, if I took this and divide the x in half, that means my x value will go from this to half. So it's going to be a horizontal shrink when I multiply. When I tell you to divide, that means I got to multiply the x values by that amount, let's say 2. So every time I divide, I do a horizontal stretch. Okay? So everything is the x value. So think of stretch and shrink in the x direction. Okay? So that's what I'm showing right here. Notice everything is inside the x value, inside the parentheses. Subtract 2 means shift right 2. Multiply by 2 means divide by 2, so it goes in. And if I negate the x, if I take this value and negate the x, it's going to come over this way. That means it's going to reflect over the y-axis. And then everything outside is exactly the same as is. So it's multiply and multiplies. But again, since it affects the y value, right? If it's adding, then I'm going up. Subtracting, I'm going down. If I'm multiplying by 2, that means this has to be twice as tall. So it looks like a horizontal shrink, but it's really a vertical stretch, right? If I divide by 2, that means I got to bring this down by half. So it looks like a horizontal stretch, but it really is a vertical shrink. Okay? So I want you guys to think of it that way. And when y values gets multiplied by negative, look, the y value goes from positive to negative, then it has to be reflecting over the x-axis. Versus this way, where the x value flips from positive to negative, it reflects over the y value. I mean, y-axis. Okay? Any questions so far? I would tell you not to watch my college algebra version of this because that one is long and confusing. I decided to compress it, so this is much better. I think it's in the second May video that this is on. Or you can wait for the August 22nd one to be posted. All right. So I'm creating 2 examples here, and we'll do the 2 examples before we go. One example is, hey, I need you to do these things here and then give me my equation. Okay? So the parent function is f of x is equal to square root of x. I want it to shift up 5 units. I need to reflect over the x-axis. I need you to reflect over the y-axis. I don't know what negate x is. I believe that's supposed to be negate. Let's fix that. So it's not negate. So the first step tells me to shift up 5 units. Is that going to be inside the radical or outside the radical? outside. Because what we got to look at is everything inside the radical would be inside the parentheses. Make sense? Everything inside the radical will be inside the parentheses. Okay. So this is plus 5 on the outside. Awesome. I got to reflect over the x-axis. So if I think about reflecting over the x-axis, which value changed? The x change or the y change? The y change, right, from positive to negative. So that means I'll have to negate the y value. Reflect over the y-axis. What value changed, the y or the x? The x changed, didn't it? So that means I got to negate the x. So that would be the equation that would come up with. So the question is, what's my expectation when it comes to the lab work in terms of showing a transformation? Because this is what you guys are going to need big time. So number one, I need to get my points from the parent function. Because I see the absolute value signs, that means my parent function is the absolute value of x. So I'm going to come up with it. Let's come up with 4 points. Give me four x values. Sure, sounds good. Are those right? Okay. So I got 4 points. -2, 2. -1, 1. 0, 0, and 1, 1. Okay. So now I got my points. You guys see where the points came from, yes? It's all from the parent function. Based on this equation here, what should I be doing first? What ought I do first? Because I'm starting from the outside, so there is now. Thank you. Mr. Chan, your mic died. So do we know where all these numbers are coming from? We're good with that? All right. Because it's plus 7 up there, that means I got to subtract 7 because it's inside the parentheses. Right? Now what do we do next? Am I still inside the parentheses? So we did the sad part. Now we got to do the MEP part, right? That means we got to multiply by that -1. Or better yet, what? Now we got to deal with this, right? That's the second step. Yes, no?
So now we're dividing by -1?
Yes. Which value? X or Y? X. So we're going to take the X value and divide by -1. Am I done with everything inside the parentheses? Yes. So now I come out of the parentheses, right? When I come out of the parentheses, what am I doing? Which value? The y value. So I now got to multiply the y value by -2. And yes, 0 times -2 is still 0. Agreed? Now here's the thing. If we think about the order that we went, right? The red tells me that I'm going to shift left 7 units. The -x tells me I'm going to reflect over the y-axis, right? And then the -2 is going to tell me to stretch twice the height and flip over the x-axis, right? Okay, now picture that in your head right now. Ready? I want to do this. I don't want this. I want this. I want this. So we were saying the absolute value of x. Let me make that, actually, let me do this. And then we had, what was it, -2 absolute value of 7 minus x, Russ? Is that what we did? Ooh, wait a minute. That's not what we did. Nope, it is.
The scale just looks weird when it's in out, I think.
Yeah, the values worked out. Yep. The values are exactly as is, right? So you can check it if you want to, right? But this is the work that you would need to show when it comes to it. So if I was to do this problem right here, right, because I see the square root, then I got to go to the parent function of the square root of x, get 4 points from that, use those 4 points, then go, okay, what do? I got to go do the +5 first, which is really -5 from the x value. And then that's the only thing inside the parentheses, right? And then I'll do I do +5, well, the +2 first and multiply by 3 first? Multiply by 3 first, and then add the 2, because I'm outside the parentheses, right? So when I see this, guys, this is my parentheses, right? What's inside the radical is my parentheses. Any questions? Nada. Quick thought, really quick, guys, just so you guys know. In case if you guys are having issues with your BibliU or anything like that, number one, when you log into Canvas, there's that student welcome to fall 2024. There is a BibliU study guide, student guide. If you click on that, you guys can see some of the things that you guys need to do, okay? Now, the other part of it that I'm concerned about is that if you guys are having some issues, I want to know, but better yet, let's let IT know, because you guys are all like lab rats for this, because it's the first semester BibliU is here, okay? And literally nothing went live until Monday, the first day of class. So whatever work they did in the back end, they were just hoping and praying that it's going to work. And then day one came, and then let's see what happens. So while you're here at this page, this directs you to the IT homepage, right? So if you go OIT home, right here, you can actually submit a ticket. So if you guys are having issues with BibliU or Access Pearson, submit a ticket. And this way, IT at least can gather information of what they need to kind of fix. If it's BibliU side, if it's Pearson side, is it user error side, it's okay. At least do that. And the other thing is that on the BibliU side of things, right, if you hit this question mark, a chat would come up, and you can submit your stuff there too. So at least you're asking the same questions to two different people, and you're hoping that one of them will help you first. So whatever you type in one, just copy paste, plug it into the other, and hoping that one of them will give you an answer back sooner. Is that fair? Okay. Other than that, ladies and gentlemen, please have a wonderful, blessed weekend. Please be safe. Love you guys. I'll see you guys next Tuesday. Later.